Hello there, and this is chapter 14. It's called Natural Resource Management, Depletable and Replenishable Resources. So, this is the second chapter on natural resource management. The last chapter was about something called renewable resources, fish in the sea, and forests. Um, this is not necessarily renewable, and we'll chat a bit about, or I'll chat a bit about um, how the pricing and allocation occurs for these two particular groups of resources. Okay, and we have a nice picture of I believe, a freshwater lake here, and and your chapter begins with noting the worth of water. And a quote here from Benjamin Franklin: "When the well's dry, we will know the worth of water." Water is the most widely used resource by industry. It is used to produce energy. It provides the basis for much of our outdoor recreation. It is an important part of our transportation network. It serves as a vehicle for the disposing of waste, and it provides important cultural and amenity values. And then with regard to water would be called a replenishable resource. Oil is a depletable resource. And here's a nice quote: "It is difficult for people living now who have become accustomed to the steady exponential growth in the consumption of energy from fossil fuels to realize how transitory the fossil fuel epoch will eventually prove to be when it's viewed over a longer span of human history." So now, these are the two resources we'll chat about in this chapter. Um, Now, time is not a consideration here in for these particular resources. We can't necessarily talk about going into the next period with oil or replenishable resources because they're not necessarily renewable. Once you use it, you to some extent lose it, or so there is a fixed supply of this particular resource. Okay, so as your author says, with oil, it is no longer a question of whether to wait for the next incremental growth in the resource. Any realistic discount rate makes the present value of supplies that may be created in thousands or millions of years virtually zero. So there is no there is no future. Once you use it, in essence, you lose it. Now, fossil fuels are going to be called depletable resources because their time frame for renewal is beyond the scope of practical consideration, and that's different from renewable because these resources can increase over a reasonable a period of time. Now, water is going to be called replenishable. Air and water are among the life-sustaining replenishable resources. They can be replenished over a reasonable period of time, and we differentiate them from resources that increase via biological growth. Interesting. These are called replenishable resources. So obviously, what you're looking at right now is a replenishable resource. Now, let's first look at the world of oil. Here's a picture of a oil storage facility. Lord knows where this is located. It could be in Louisiana. It could be in Los Angeles. Plenty of oil being stored in Los Angeles that comes off of ships. Although Los Angeles itself has quite the history of um, producing of drilling for oil and of course refining oil to make gasoline. Now, since oil is a fossil fuel, it is in relatively fixed supply, so it's depletable. There, the question is, yeah, well, fixed because it has a finite resource and does not grow like trees in the forest. Although, even though, yeah, that's right, that's why it's fixed, and relatively because we can and do find more of the stuff given market prices. Now there was a person in 1956 named M. King Hubbert who correctly predicted that U.S. oil production would resemble a bell-shaped curve, reaching what that better became known as Hubbert's peak in the 1970s and then declining. Um, Oil companies would discover additional resources over time, and supplies that are not economically viable today will become viable with improved technologies. We know there's a peak, but we're never really quite sure when that peak is. You probably have heard the term peak oil. It's hard to find out where the peak is because, given market prices, we're always finding more oil to be drilled for. One thing we do know is that that oil that we find is going to be increasingly difficult and costly to be able to get at. This includes deep water oil. This includes oil that comes from fracking in the United States. It's just more and more difficult and costly. Difficult equating with costly, the finding of oil. Okay, your author mentions a rule, an interesting rule called Hotelling's rule. Harold Hotelling in 1931, he studied the specific relationship between the discount rate and the stream of economic rent, which is price minus the extraction costs over time. His famous conclusion, known as Hotelling's rule, was that in competitive equilibrium, the marginal rent must rise at a rate equal to the discount rate. And I think this is the um, this is the key phrase right here. Hotelling's valuation principle, that the value of mineral reserves can be estimated as the current price minus the marginal cost multiplied by the estimated volume of extractable resources. So in other words, as costs increase, the price of oil will increase relatively predictably throughout time. As you can see, though, oh, by the way, and this is Hotelling's rule and valuation principle, and the implication is that oil prices will increase predictably throughout time given the increasing marginal cost. Now, looking at the graph to the right, what is happening to oil prices? Well, you can see that they are kind of increasing somewhat predictably from the 90s um, through to the through to the early 2000s, but then 2008 and then 2010 came along, and you have a massive spike and then and then hurtling downward in oil prices. So something else is going on with regard to oil prices. It doesn't follow Hotelling's valuation principle exactly. And so what could be going on? Well, your book talks about known supplies are not rigidly fixed, and some resources are not as homogeneous as Hotelling assumes. So um, yes, it's harder and harder to find oil, and there's different types of oil. It's not as homogeneous as one might think. There's heavy crude and light crude, um, and they have different uses, and the ease of using one is different from using another. The author also goes on to say that extraction industries are also capital intensive, making it difficult for them to respond quickly to anticipated price changes. So that is exactly true. To get a deep water well up and going is millions upon millions of dollars to do that, and so it can't respond as quickly. I also would add political events have a major impact upon oil prices. Oil tends to be located in areas that are very much suspect to uh, changes changes in they're subject to changes in political climate. I'm thinking about Iran and perhaps Iraq, subject to changes in war or the threat thereof. I'm thinking about what happened in OPEC in the early 70s when OPEC decided to the countries in the Persian Gulf decided to band together to ratchet up oil prices. So these things are very, very politically driven and not necessarily subject to a nice predictable linear line that Hotelling's valuation principle implies. Okay, this finishes up our first section of this chapter.